Hi, welcome to part 4.5, we'll call it, of creating a DLX architecture simulator. Um, the reason we're calling it 4.5 is because today we're going to work on our logging system to kind of output stuff to a file where we can view what's been going on with the simulator as it's been running. Um, and the reason we're calling it 4.5 while we're doing this is because it's optional. It's not something you have to do. I like to have a logging system in place so I can kind of check out what's going on, but it's definitely not necessary. So if you don't feel like putting a logging system in, you can definitely skip this video and continue on to the next one. Otherwise, we're just going to create a logging system. So to start, we're going to create a source and a header file like usual. So create new item. This will be our source file. We'll call it logger.c. And then we'll add a appropriate header file. Call it logger.h. So we'll set up our header guards. Include DLX logger h. Define DLX logger h. And we'll make sure we spell include right. Oops. If and def. Alright, so we're off to a great start already. Alright, so in here we're going to have a static struct. Well, let's first start by creating a. Let's go here. We're going to include logger.h. And then we're going to type def struct logger, and in it, it's going to have a file path, and then we're going to have some type defs in here as well. Logging functions, logger, and we're going to have to put some functions in here. So how we want to do this is going to affect a few things. So typically what your logger does is it'll print out the severity of whatever it's logging and then the string. So if it's an informational thing, it'll print like info. If it's a warning, it'll print a warning message, and if it's an error, it'll print an error message. So you can print debug messages, all kinds of stuff like that. So what we need to know is how we want to handle those. So what we are going to have to do is start by writing those functions. Let's start there. So we're going to have void log warning, and then it's going to take in a message, and then we're going to have void log. Actually, let's start with the lowest severity. So void log debug, and then we'll have void log info, and then we'll have void log warning, message, and then we'll have finally void log error. So now that we have those, what we want to do is we want to have a function pointer for the logging functions. So let's actually change these to just debug info warning and error. Let's not put the log in front, and that'll become apparent very shortly. So let's start by going type def, and we'll say logging. Sure, it's called logging, I guess. and then it'll take a char pointer, which is our message. So we'll have logging debug equal no, can't do that. Logging info logging warning. We'll call it warn and logging error. So now what we'll have to do here is have a variable set as well that we'll just have a flag. So we'll call it a. We don't really have a Boolean, which we could do. We could create a Boolean. But we'll just use an int for now. Int debugging. So this is for if we want to set the debugging flags that we can use debug. So what we'll do here, let's have a logger pointer, which is logger. That's because we can't do that there, so we have to. I think if we go and put struct logger, and then we go typedef struct logger. That has to go after. I'm pretty sure, actually, now that I think about it. So I'll put that after, and then we'll call this struct logger. Okay, so the reason we're doing this is because this is going to get really crazy. We're basically creating a C object, or C++ object. So we're going to pass in a logger to all of these. Actually, no, we don't need. Do we need to? Let's take this out for now. Let's revert what we just did. And let's first take a look at what we're doing here. Struct, or typedef. So let's take this out. Okay, let's start right here. So we're going to need a function, logger, a logger return where we're going to create a logger. We're going to need a file path. And then we'll have a int, I guess, create or initialize logger. So pass the file path in there as well as the logger. So, and then we'll have to have a int destroy logger. So now if we go here, we're going to need to put some function declarations. And we'll have logger. So logger is going to have to, I guess, go into here. It's going to have to go in the header file. So let's print that. Logger struct. I'll have to move the function definition in there. So let's, or the function pointer in there. So these should all go away now. So we got logger, create logger, and then we're going to have int destroy logger. Okay, so now that we have these, we can start. We'll start by doing the create, initialize, and destroy as we've done it for everything else, and then from there we'll start tackling actually printing stuff out. We're going to do it a little bit, see if we can do it the way I want to do it. which is by calling logger and then dot or point to the function call. So we'll see if we can get that done. But for now, we're going to create the logger. So logger equals logger pointer malloc size of logger. We should include the standard DLX sim. And does that include errors? It does. Okay, perfect. So we got that included. We have malloc now. So now we can call initialize logger. Actually, first we want to see if logger does not equal null. Then we want to initialize int status equals, so let's add some error stuff here. Logger errors, define logger success is 0, define logger general init error equals -1, and define logger no memory error equals -2, and then we'll have define logger file path error equals -3. So that's going to be for if we can't find where they want to store the file to. So int status equals logger success, and then status equals initialize. We're going to need the path and logger. So this has to be declared up here. So initialize int initialize logger, char pointer and logger pointer. So that's good now. And then we're going to say else. So if logger is null, then we're going to want to printf. The stream is going to be std error, so standard error, and no memory to allocate the logger. I should have to say unable to allocate memory for the logger. And then new line. And then we'll say status equals logger no memory error. And then we'll return logger. Logger. So this doesn't really make a difference because we can't really we don't really use this, but it's there in case we have something in the future we want to use it for, or if we want to return it later. So we allocate memory if we can. Boom. We start initializing the logger. If we can't, we print to the standard error, which will just output to the console, and then say unable to allocate memory for the logger, and then return this. And if the logger can't allocate memory, it's not as big of a deal. We'll just have to handle that if we can, or when we need to. So now we have initialized logger. So we're going to need to set the file path to equal file path. I also need a debugging int debugging int debugging. So let's update all of these now to get that, which was actually we don't need to do that. We can do it a little bit differently, and what we can do is say if And I'm just going to look up the flag really quick to make sure I know which one it is. So we have ndebug and dndebug. So if dndebug, which is if do not debug logger file or debugging equals 0, else logger debugging equals 1, which is true, and if. So this says if the do not debug flag is on, we want to set debugging to 0. If the do not debug flag is off or false, that means we are debugging and we want to be equal to 0. So this is the same thing. So we're going to have to include another header in this for that to work. I'm pretty sure it's in assert. I know it's in assert for sure, because this is how you disable asserts. Use the do not debug flag. So we'll include it just in case, but I don't think we should need it. Actually, let's remove it and we'll see if we can go without it. So, actually, no, I think it is. We'll include it, because that we can also use asserts if we want. So yeah, we'll include that, and then we know for sure it's in there. So let's close the header file. Okay, so we have those set, and then what do we have here? We have so now we have to set the functions. So we have so let's set a status here. So int status equals logger success. And before we set this file path, let's go file f equals fopen, and we want file path, and we want write binary. Actually, we want to add a append into there. So we're going to need to use the flag. I think it's A. So actually, no, let's do R for reading, because that way, if it doesn't exist, we get a null. So we can say, so if f equals null, that means we file doesn't exist. Actually, that could be fine. No, let's use A plus. So reading plus appending, and data is appended at the end of file. So if it equals null, that means that the problem with the file path. So we need to say actually, I'm going to put this in the new line. So we're going to need to say status equals logger file path error, and we're going to need to fprintf to std error unable to use the file path specified. We'll put it in brackets, %s specified, and we'll print the path out too, so we know where the path is. And then what we'll do is we will we'll call destroy logger, and then we'll return. Actually, let's not return. Else. Here we want to set logger file path equals file path f close f, and then we'll move these into there, and then move that, and then return status. So, just to reiterate what goes on here, we try opening the file, and if we were successful, what we'll do is we'll open the file. If we can't open it for some reason, we'll print that we're unable to use the file path, and then we'll destroy the logger because we can't use it. Otherwise, we'll set the file path to be the file path, we'll close the file, we'll set the debugging, and then we'll return status. And what we'll also do here is we will we'll call info, and we'll print success starting new. So we'll do this before we close the file. We'll print starting. We'll print creating or opening new. We'll print logger initialized starting. I won't say it yet. So now logger initialized. That's what we'll do. New line. So these aren't. That hasn't been declared yet. So well, hasn't been forward declared yet. So we'll just leave it for now. But so we have, if we weren't able to initialize the file, we printed the error, we printed the std error, we couldn't do it, and then we destroy it. Otherwise, we'll come down here, we'll set the file path, we'll set the debugging flag, and we will write using the logger that it's an info that we started it up, initialized it, and then we'll close it. So now that that's done, we can write destroy logger. We can free logger file path, and then free logger. So that'll just kind of clear out the path char pointer, and then this will destroy the logger itself. So if we go now to main.c, to destroy state machine, we also want to destroy the logger. So we're going to want to add into here include DLX sim. Does state machine.h include it? I guess it does, so we don't need to. So we need to add to DLX sim.h include logger.h. So that way everybody has access to logger. So before we create the state machine, we want to create the logger. Create logger. File path. We'll pass in null. That's one thing we should do. We should handle null. Because what we're going to want to do is we're going to be able to have the user say, I want to pass in a specific path and have it go there, or no path and have it default to the default path or the current directory. So we'll create the logger, and then if it's not successful, we'll destroy the logger. Otherwise, we'll run the state machine, and then I think in run state machine we have destroy state machine, destroy logger. Actually, we should put that in main since the logger's not going to be there. So let's put that here for now, destroy logger. So we can actually delete this one. This one will be, go down here and call this one no matter what. So we'll put that there for now, and we'll see where that takes us. So let's go back to Logger and let's handle null file path. So if file path equals null, then so let's go char file path equals null. So if that's true, we want file path to be equal to current directory. Otherwise, we want it to equal file path. So this is just a conditional operator, which says if this is true, use this. If this is false, use this. And it's just a one-liner if statement. So just really simple to do. So yeah, we'll set it to the current path if it's null, and file path if it's not. So this is kind of a messy function, so we'll add some comments to it. So we'll say set the file path to current directory or specified directory. Try opening the file to see if the path exists. And then the rest should be pretty self-explanatory after that. But it's just these two that are kind of look a little bit more intimidating than they are. So we create it. We come in and we actually create it. We initialize it. And then we return that. And we return the logger. So we should check here now if status does not equal logger success. So if we couldn't successfully initialize it, what we want to do is we want to have a fprintf standard error couldn't initialize the logger, and then destroy logger. Yeah, so there we go. So if it wasn't successful, we just come back and we destroy it. So this is the case where we've allocated the memory, but we couldn't initialize it for some reason. So logger file path error seems to be the only one, so we actually need to destroy this. We can just print. Because that's already destroying the logger here. So it is handled here. So actually we don't even need to handle it now that I think about it. But okay, so that's all good now. So let's write these. So we need to now logger logger object. We'll call logger object right now. So we're going to have a static logger logger. So I think what we can do now is instead of returning the logger, we're going to change this to an int, and we're going to return status. So now let's go back to main, and we'll say int logger status equals create logger. So we're going to have to redo a lot of this now. So logger status equals create logger, and we should handle this. So what we need to do is, where do we all call logger stuff? I don't think we do in here, so we can close that. So let's first create a logger the way we want to. So we return status. So if status does not equal logger success, actually if it does equal logger success, that means that we've created it and we've initialized it and it's working. So what we want to do is set, so let's change this to L so that we don't get our names confused. Change all of these to L, 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 L. Okay, and then L. And then what we'll do is we are going to set logger to be equal to the address of L. Or is it the dereference? Okay, so the dereference to L. So now that we have this, L. So what this does is it says we're going to do everything the way we were before, but actually we should just go like this and go logger L equals address of logger, and then free that way. So this is a object that will stay through every time we create this header or call this header. So essentially this object will be the same object forever and ever. It's almost like a constant. And this is what we can then use to log stuff. So we can have our functions in here forward declared. So we have void. These are all voids, yeah. Debug char, void info char, void warn. Is it warn or warning? Warning. Char, and void error char. So now these are all forward declared, and then as part of the initialization, we want to set, I just did above here, set functions, write functions, set file path, and set debugging. So now we have if, or no, we're going to go L debug equals debug, L info equals info, L warn equals warning, and L error equals error. So there we go. Now we have all these included in the logger. And then yes, okay, perfect. So now our logger has all the functions to actually write stuff added. So we're actually going to do this now. We'll add the writing stuff. So file f equals fopen logger dot file path, and we're going to open it so append mode, so we append to it, and then we'll go fprintf f, and we're going to go debug, and some kind of weird, just a little string for us to kind of separate the string text from the default header text. So we're going to pass in message, and then we'll fclose. So this opens the file in append mode, and then we print a debug statement, a string, and then the string message that's passed in, and then we close the file. However, we only want to do this if we are debugging. So we can actually kind of make this smaller. And we only want to do this if it's debugging. Otherwise, we just don't want to do anything because they're not in debug mode, so we're not going to print debug stuff. The other thing we could do is we could actually specify it's a debug file by appending debug to the path. But we're not doing that for now. Oh, the other thing we should do is add a file name here. So let's go log DLX log or DLX.log. If they pass in a different file, they can specify the file name. So they'll have to do that. So now in info file f equals f open logger.file path a, and the reason we have to use the dot is because it's not a pointer. It's not a pointer, it's just an actual struct object. So we have to use the dot syntax. F print f info, and then %s for the string message, and then we'll close it. So we'll do this for all three, just changing the little characters that are put in front of it. So fopen logger.file path append mode, and then print in here warn %s message. And we have to close it after we're done every time so that we can make sure it's the next one can open it. So equals f open logger.file path, and then print error, and then f close. Oh, not pile path, we want file path. Alright. Perfect. So now we've got our logging system in place. Whether or not it works, we'll find out, but it's in place. So, now, if we want to use it, so logger status. So, we should add another one here, and we'll call it define logger initialized. And we'll set it to 1. So in logger.c, what we'll do is in here, status equals logger initialized. So that means it's fully usable. So if logger initialized, so this is the only pain, is whether or not it's initialized. We'll see what happens here. If we have no memory, it doesn't get transferred over. So let's destroy this. Actually, it hasn't been created. So let's determine, what we're going to want to determine is how we want to handle if the logger's been created or not. So if the logger hasn't been created, then, so if the logger can't be allocated memory, then every time we have the dot, it's not going to work. So we can either put an if statement before every call to logging, or what we can do is, we can say actually, let's have a flag. So int argc char argv. So if argc is greater than 2, 1, if argv1 equals logging dash logging, or argv1 equals dash l. So what we're doing here is we're just going to check to see if the user wants to enable logging. So if we want to enable logging, yeah, so for right now what we're going to do is we're going to handle it this way. You pass a command line argument for -- logging or -l, and if you specify one of those, then we'll create the logger, and if logger status does not equal logger initialized, then we're going to say return -1. So if essentially if you want to create the logger, if you want to log and a logger can't be created, you don't get to run the program. If you do want to run the logger and it is created, you can run the program. And then if you don't want to run the logger, it just runs the program. So, well, actually that doesn't help anything because that just says, just helps in here. So int logger status equals create logger null. So if we want to log now, let's see, what do we have for options here? We have loggers going to be null no matter what. So yeah, let's just handle this here. So if logger status does not equal logger initialized, return -1. So yeah, if the logger isn't created, we're just going to quit, because we want it to be created no matter what. And then if we don't want to use a logger, we just remove these lines. So because we want to use a logger, we're going to do that. So let's actually create a function here. Void setup logger. And let's put this in there. And then call setup logger. So we can't return anymore. I guess, yeah, let's just put it back then. It's not worth creating a whole function for that. So exit if the logger can't be created. So yeah, let's remove this then and set it back to void. Okay, so yeah, if the logger can't be created, so logger was created, start the program. Perfect. Okay, so now what we can do here is go. So we had to do log this, so we can say logger dot error, and our message is going to be could not, our state machine was not created. And then otherwise we can go logger.info state machine was created, starting the state machine main loop. Alright, so now, the moment of truth, we'll try running it. There was build errors. Okay. Oh, this one does not have an int. should change this to file path. Okay, so that should kill both the errors we had. So debug assertion failed. Alright, so what do we got here? So this is where we are. So file path is null, which is why we can't fopen it. Okay, so let's see why the file path is null. So what we're going to do is we're going to set a breakpoint right here. Alright, so stop first. No, that's not what I wanted to do. Where do you set breakpoints again? Is it this one? There we go, okay. So, let's try running this. Okay, so file path is null. So, it should set it to /DLX log. Let's go to the next one. File path equals DLX log. Okay. So that's fine. So let's go over that. File path is DLX log. So skip over that. And now this is DLX log. So if we go to L, we have DLX log. Okay. So let's skip that, skip that, skip that, skip that. Debugging is 1 because the do not debug flag is not set. Perfect. So let's step into this. Ah, there's our problem. We're using this system before we've actually created our before we've actually set the logger. We're trying to use it. Okay, perfect. So let's go instead. Let's just fprintf for now. Info. Actually, let's not do it there. Let's do it here. Info logger initialized. Okay, perfect. So yeah, so we were trying to call this and use the logger object before the logger object had been set to what we've declared it all as. So let's try running it now. Alright, so we've got another problem. Break. What's it here now? So logger is null. Okay, so our logger object still hasn't been handled properly. So let's go back and take a look. Let's set a breakpoint there. And alright, so we're here. We've done everything else. Actually, stop it. Let's start again. Okay, so logger equals nothing. L is what we need. Okay, so step over that. Logger is everything that we need. Perfect. So let's go step into it. Alright, so we print, we close. Perfect. So we initialize, return status. Alright, so now that's done. Logger status equals 1, which is initialized. Perfect. State machine is perfect. And state machine error is 0. So that is success, I believe. Yes. Alright, so logger is all zeros. Okay, so where does it get set back? Let's restart. So logger is set there. So as soon as we get back, it's at zeros. So that is not what we want. Is this one still? So let's just make this a pointer then. Let's see if that fixes it. So we have to change all of this now. So equals L. And this changes to that. That changes to that. That goes to that. And that goes to logger. And then these all get changed to these. So now if we try running it again, ignore, break. That's because we changed all that. So let's go like this. Alright, so now let's try this, see if this fixes it. So logger, null, and that's the object we want. So now it's equal, and return, and logger is null again. So why is it nulling out like that? So let's go like this. Let's try this. Go. Can we only use one of these? Show me what the error is. Oh, let's stop this. Okay, so let's try. Okay, so let's set it as an external. And then in here, we'll have logger Alright, so let's try that. Alright, so that worked. If we go to where our project is stored, alright, we opened it, boom, logger initialized, many initialized, state machine was created, starting the state machine main loop. Perfect. So it's working. Now, I don't know how it will handle if we give it a bad path, but it's working. So now we can go to, and is it possible to use something to find no. Let's just go through and find it wherever we've had. So it'll be in our C files where we'll have to do log this. Alright, to do add logging. So we'll go logger error registers could not be created, destroying cannot be initialized, destroying the register freeing the register memory. Freeing the memory allocated for the registers. So, I mean, you can print whatever you want there. If there is no memory, then I'm going to logger error unable to allocate memory for the registers. In here, logger error unable to allocate memory for the general purpose or floating point registers. So let's put this has to go here. So we'll be able to add more, but right now I'm just logging the errors. State handler. We'll put in logger dot error, unable to initialize the state, freeing the memory allocated for the state. And in here, we'll put in unable to allocate memory for the state. And then that's good enough for now. And then in here we have error logger error unable to allocate memory for the state machine. And in here logger error unable to initialize the state machine, freeing memory allocated for the state machine. And then what we'll do is inside the logger, we will put in the destroy. We'll put in first info, destroying the logger. And that way we know it's been closed. So we haven't used warn, we haven't used debug, but we definitely have those, or info or debug, really, but we do have those options, and we'll be able to use them in the future. So if we run this now, alright, and if we look at our text file, we will now have state machine was created, which it should say more than that, actually. So let's go through and see what our loop does. So we have run state machine. So this isn't executing apparently. Let's see. It does. Okay, jump in. Process state. Oh, yes, it won't print anything else because those are all errors, not... That means it was successful. Alright, so perfect. Okay, so here we can do a debug logger debug entering the or executing the fetch stage. So here we don't have access to logger because we include DLX sim. DLX sim has logger. Oh, we need to use the right one. Debug entering or executing the fetch stage. And then we could print like debug instruction fetched and then print the instruction, all kinds of stuff like that. But that's going to get very full very fast if we do that. So we won't do that for now. But the logger is working and it's doing what it needs to. So we can now log everything that we're doing in this file, in this program, and see kind of where we are with what we what's going on, and we can print out information and kind of see what happens as the execution is going on, and in a nice little simple log format. So this will uh, so I don't know why it's not printing out that it's destroyed the logger. Let's take a look at that really quick. Let's put a breakpoint there and see if it's actually called ever. Oh, so it's not. Alright, so we want to hear destroy logger. And logger.h. We don't need this anymore. So, and we don't really need to print. Do we return for anything else that's destroyed? Return success. Okay, so return. Oh, the caps lock is on. Return logger success. Okay, so we can take this out now. So yes, now it will print out that we successfully destroyed it at the end. Oh, but apparently we can't free file pass, so. Which makes sense, because we don't actually allocate memory for it, so. Perfect. So now if we look at DLX, destroying the logger. Perfect. So yes, we have now destroyed the logger at the end, and printed out that we did that. So, no errors is good. We can do warnings, we can print errors, we can print information, we can print debugging, and debugging will only print if we set the do not debug flag, which we'd have to set in the command line arguments. So that is our logging system, which we can now use to print out information as we need it. So with that, in the next video we're going to start implementing actual instructions. We're going to start implementing actual instruction functions. So functions for stuff like add, subtract, or add, multiply, subtract, all those good stuff. So we're going to be using the actual registers for that, and hopefully that will put us to the point where we can almost finish up stage 1, and then from there we'll create file reading and have to write an interpreter for our language and all that kind of fun stuff. So until next video, happy programming.